Hey 6th grade, welcome to your first video lecture. If you have not done so already, go onto your class Google Doc and please click the link to the lecture slides and have them open their Google Slides. They're also in the description below. Yeah, get me views, watch the videos. What you need to do today is, while you're pulling up the lecture notes, you need to follow them along and take good thorough notes on what we're doing. Please make sure you do also talk about in your notes like what I've said, not just what's on the screen, like you're used to, how we always take notes. So, if you look at the first slide, it says warm up. Who discovered the force of gravity? Well, I will give you a hint if you don't know. An apple fell on his head, and he went, oh my goodness, this is gravity. Not really, it's not how it happened, but give you a second. Pause the video if you need more time. The answer is Sir Isaac Newton. Alright, so what we're going to do is we're going to start talking about physics, and we're going to go into talking about Newton's laws. He made 3 laws about motion and how objects move and all that kind of stuff. So it's chapter 8, pages 90 and 91 in your book if you want to follow along in that as well. The first thing I'm going to talk about are the scientists, researchers, whatever you want to call them, themselves. Aristotle, Galileo, and Newton. You've heard of Aristotle before. He's done pretty much everything from science to math to philosophy. Galileo did a lot of earth science, and Isaac Newton did a lot of physics and math. So all of those men saw the laws of motion as unchanging principles, meaning that these laws or principles that they came up with to describe how objects move are unchanging. Like, motion always happens this way, and that's it. Aristotle was one of the first to say that exerting force on an object makes it move. So whether you're like pushing, pulling, whatever, if I have a ball and I push it across the floor, it's going to roll. I exerted force on that ball and now it's going to move forward. Newton, one of the first things he saw, as we discussed in our warm-up, was the guy that figured out that gravity pulls on an object regardless of whether it's touching it or not. Well, it won't. As we know, gravity pulls towards the center of the Earth. The Earth has its own gravity. There's gravity all throughout our solar system. The sun's gravity holds all the planets in its orbit. The Earth's gravity holds the moon in its orbit. And gravity is what keeps us from floating off into space. And think about it, for you to stay grounded on the Earth, do you have to hold on to anything? No. So gravity is a natural phenomenon that just works without having to touch anything. And gravity is different on different planets and all that kind of stuff. So the first slide has 2 your vocab words. Force and inertia is how you pronounce that. You've probably heard of these before. Force is defined as the push or pull on an object. So in my rolling a ball example, I put force into moving it. I pushed it forward. Inertia, on the other hand, is defined as the resistance to a change in motion. So think about my rolling ball example. If I push it across the floor, it's going to keep going in that direction until something makes it not. So let's say I push it across the floor and then my sister knocks it to the side, it's going to go the other direction, right? So inertia is the resistance to change in motion. Every object has inertia based on how much force. Sorry for the sniffles, my allergies are terrible. How much force has been acted upon it. Okay. So the next slide you'll see is Newton's first law. He made 3, well, he made several. We're going to go over 3. The first one states that an object at rest tends to stay at rest, and an object in motion tends to stay in motion unless acted upon by an outside force. Basically, this is saying if I have my ball sitting on the floor, it's not going to do anything until there's a force put upon it. Like if I push it, or my sister comes and kicks it out of the way, or whatever. The other hand of this is that an object in motion tends to stay in motion unless acted upon by an outside force. So if you look in the GIF there, you'll see a bunch of like little balls rolling down that ramp. And they're going to keep going until something makes them stop. Whether they hit a wall or somebody catches them. There is a thing that does make everything naturally stop. You've heard of it. It's called friction. It's rubbing. So those little balls that are rolling down the ramp will eventually stop because of the friction of the ground. Even if it's a smooth surface, there's still some amount of friction that stops it. Otherwise, anything that would be moving would just move forever and ever and ever and would have no way to stop. So, friction is really the main thing that makes things stop. Okay. I hope that makes sense. Because now we're going to go to the second law. This is going to be a pretty short video. Yay! So Newton's second law, this is where he gets into some of the math side of it. It's really simple though, all you gotta do is multiply. So this is where he says force is the mass of the object multiplied by its acceleration. We'll get into acceleration and velocity and all that in our next lecture. But you'll see at the bottom there, I wrote the little equation or the formula. So force equals mass times acceleration. And we'll get more into the math later, but if I give you an example now, let's see if I want to know what the force is of a rock falling. Like I picked up a rock and dropped it. And how much force it is to drop to the ground. Oh, how much force it has. So let's say that rock has a mass of 1 kilogram. And we take the acceleration of gravity in this case because it's being pulled down to the earth, which is 9.8 meters per second squared. What we would do is multiply those two numbers, and because it's 1 times 9.8, it equals 9.8. And then we measure force in something called newtons. We named it after Isaac Newton. So the force for that imaginary example rock to fall to the earth is 9.8 newtons. Simple. Multiplication, your unit is a newton. That's it. Alright, so when you apply this law to how objects move, it's pretty logical. So the more mass an object has, the more force it takes to change its speed and direction, which is acceleration. Okay, acceleration is a comparison of speed and direction. If you look at a little picture, you see a little toddler pushing his dad on the swing. Well, you can imagine that it takes a lot more force to push the adult on the swing than it is the toddler. And it's going to take that little toddler a lot more force to push the dad, for the dad to push him, or someone else to push him. So this logically follows that the more force that is applied, the greater the change in motion. So if we go back to the rolling ball, if I set it on the floor, here's the ball, and I poke it, shoot, it's only going to move a little bit. But if I shove it, it's going to move really fast. I don't have a ball with me, I'm sorry. But you can imagine. I'm so sorry for the sniffles. The pollen is trying to kill me. You should see the outside of my house. It's completely yellow. I'm sure yours is too. Okay, so that was the second law of Newton's second law. All about force. His last law states that for every action, there is an equal and opposite reaction. Now this may sound really weird, but it's quite simple. I'll get to the football example in a minute, Don't worry. So, every action you do, there is an opposite reaction. If you think about like a rocket that's going into space, the engines are going to start and they're going to thrust out all that gas to push it up into space. So, the gases and on smoke and stuff are going to thrust downward. But because they're thrusting downward, the rocket ship goes up. So when the gas thrusts down, the opposite reaction is that the rocket goes up. Okay? The same thing as if you've ever seen a Weeble Wobble doll. They weeble and wobble, but they never fall down. You push it, it kind of falls, but it bounces back up. It's the same idea. So if you look at the football gif there of the Penn State game, no, I don't remember what game that was. It looks kind of old. But you see number 99 goes and tackles the guy in white. I can't see what number he is. 24 maybe? Whatever. It's the guy that has the football and falls down. So, number 99 at Penn State, he runs into that guy. And you'll see at first there's a bit of resistance. Because they're two objects in motion, but they're two objects that are going different directions. So the Penn State guy is going this way, and the guy in white, I don't even know what team that is. Guy in white's going this way, and they're going, but the Penn State guy has more force, so he goes and hits him, and the other guy falls down. So the equal opposite reaction is the amount of force he applied, that they applied, they're both going to go this way. Okay? You'll see. Even though the Penn State guy stayed on his feet, the other guy lost his balance. But they both, when they hit, they both kind of ricocheted off each other. That's the equal opposite reaction. So your homework is the final slide. I just want you to come up with 3 examples total. So 1 for each law that you could think of in your daily life. Alright? That's all for today. Please make sure you're doing all your science work. If you're not doing it, it's gonna hurt you in the long run. Remember, it's all for a grade. Okay, stay up to date. Email me with questions. Bye.